Hi. In this exercise, we're going to find the zeros, all the zeros of this polynomial, right? X to the fifth. So that means that we need 5 zeros. Not necessarily different zeros, but we need 5 zeros. So again, we're going to start by doing the list of possible zeros. So in this case, this is P over Q. And because the leading coefficient is 1, so that means that my possible list of 0 is going to be all the factors of 120. Why? Because we are going to divide each factor by 1. So that means that it's going to be exactly the same number. So this is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6, plus or minus 8, plus or minus 10, plus or minus 12, plus or minus 12, plus or minus 15, plus or minus 20, plus or minus 24, plus or minus 30, plus or minus 40, plus or minus 60, and plus or minus 120. So that's my list of possible zeros. You can see we have a lot of possible zeros. So I'm going to use the Descartes rule of sign to check how many zeros I'm going to have positive or negative to see if I can eliminate a part of that list, right? So in this case, again, I'm counting the changes in sign from one term to the other one. So from positive to negative. So that means that I have 2 changes, positive to negative 3, negative to positive 4, and positive to negative 5. So that means that I'm going to have 5, and again, I'm going to reduce that by 2. So 5, 3, or 1 positive roots or zeros, right? So because that first one is the same as the index, that means that I should have 0 negative roots. If you want to check it, you can find what P of negative x is, and you're going to see that you're not going to have any changes in sign on that one. So that means that from all that list of possible zeros, I'm just using the positive because I know that there's not going to be any negative zeros. So in this case, I'm going to go one by one. I'm going to do division. So I'm going to start with 1. 1, negative 15, 85, negative 225, 274, negative 120. And I'm going to division to check if this is a 0. So I'm going to start by bringing down the 1. 1 times 1 is 1. Negative 15 plus 1 is negative 14. This is negative 14, right? So negative 14, this is negative 14. 85 minus 14 is 71. Negative 225 plus 71 is negative 154. Negative 154 times 1 is negative 154. 274 minus 154 is 120. And 120 times 1 is 120. So that means that 1 is a 0 of this polynomial. So now, I should check if 1 is a double 0. Okay. In this case, I will. Okay. So we are going to check again if 1 is a double 0. Right. So I'm going to bring the 1. 1 times 1 is 1. Negative 14 plus 1 is negative 13. Negative 13 times 1 is negative 13. 71 minus 13 is 58. This is 58. This is negative 96. And as you can see, 1 is not a double 0. Another way of checking if it's a double 0 or not is by graphing that polynomial. Right? If I graph that polynomial, I'm going to check how many times that graph intersect the x-axis, and from there know how many zeros are have. If I trace this polynomial, I'm going to see that it should have maybe 5 intersection of the x-axis. So I know that I have 5 real zeros and none of them are repeating zeros. So, okay, but I just wanted to show you how to check just by division instead of using the graph. So my next step, I'm going to go to the next on the list, that in this case is positive 2. And I'm going to use 1, negative 14, 71, negative 154, and 120 to do my division. Instead of using all those numbers again, I'm going to use those numbers right here that gave me 0 first. Why? Because I want to reduce that from to the fifth to a quadratic polynomial. So I'm using 1, use another color, 1, negative 14, 71, negative 154, and 120. Okay. So I'm using 2 to do my division. Okay, let me fix that. See right here, so 120. So it's 1 times 2 is 2. Negative 14 plus 2 is negative 12. Negative 12 times 2 is 24 negative. This is 47. 47 times 2 is 94. This is negative 60. This is negative 120. And this is 0. So I found my second 0. Again, I already traced the graph, and I know that there's no repeating 0, so I'm not going to check 2 again. I'm going to go to my next one. And this one, because it's finishing in 60, I already know that all those factors from here, that when you multiply, don't give you 60, we don't need to use. So, for example, I can cancel out the 8, the 24, the 40. I know that those are not going to be zeros again. So I'm going to use 3. Why 3? Again, 3 is my next one on the list. Again, I trace the graph, and I know that there's no repeating 0. So I'm going to bring down the 1. 1 times 3 is 3. Negative 12 plus 3 is negative 9. Negative 9 times 3 is negative 27. Negative 47 minus 27 is 20. Right? 20 times 3 is 60. And this is 0. Again, I found my first 0. Let me shade them. Let's be correct. I found my first 0, second, third 0. So that means that I already have 3 zeros. Okay, so I reduce this 3 times to x to the 4th, then here to x to the cube, and now x squared. So I have my equation here is x squared minus 9x plus 20 equals 0. And we can just factor that by finding 2 numbers. Then when you multiply, give you 20, and you add, give you negative 9. So this is x minus 5 times x minus 4. So x minus 5 equals 0, x minus 4 equals 0. So plus 5, x equals 5, plus 4, x equals 4. So my zeros are x equals 1, 2, 3, 4, and